To start, open up the PLTW Engineering Essentials Gears. Now make a copy of it. Change your document file name. Add your name. And then click OK. Make sure you are in the PLTW EES crank. So this is the assembly file which we will be adding on. Click Insert. Let's add a 12-tooth gear and a 60-tooth gear. Let's add one 3-inch shaft and then 2 spacers. 1, 2, and then let's add 1 shaft bushing. Click on the arrow beside the rubber shaft and choose the second one. Add 2 of these. Click check. Now let's go ahead and assemble. The first one, the crank, already has a revolute mate. All we have to do now is just to add the gear. But before we add the gear, let's add a spacer. Select fastened mate. Zoom into the spacer. Choose the inner circle. And then click where the shaft is inserted. Click. If your spacer went inside, go ahead and click the flip primary axis, the arrow. If not, if it looks just like mine, just hit the check. Next, to add the gear, let's hide some of the pieces that are here. So right click on the crank and then hide it. Right click on this part and hide. And then this one as well. Right click and then hide. Okay, next, let's add the gear. We are going to use a fastened mate again. And you want to select that inner square. Okay, the technique is to select that inner circle, and then that inner square will show up, and then click, and then on the shaft, just select the center of that circle. Click. It will attach like so, and now we have to offset it up to the point where it's touching the spacer. So let's try, and we are going to offset on the Z axis. Let's try 1. Let's change it to 2. Okay, 2 is too much. Let's say 1.50. Okay, now we're going to work our way in. How about 1.55? Okay, not quite. How about 1.58? And there is still some space there, so let's say 1.59. Okay, hit check. If yours differ, just look for the number that would make this gear touch the spacer. Okay, now go to the left side and turn on the parts that we hid. Just look for the ones that are grayed out. And as you can see, I have it now here. And now the gear moves around. Okay, just for good practice, we normally add a shaft collar in order for that gear not to move out or slide. So let's put a fastened mate on this collar. And let's go put it here. And then as you can see, it went inside. So I'm going to flip the primary axis and then click check. All right, next, let's grab this part and select fastened mate. And we'll have to look at the inside part, the inner square. So we need to select the inner square Okay, so that's that. And then let's select the top of this shaft collar. Click check. They're mated together. Next, we need to put a revolute mate. So click revolute. And we need to select that circle, the inner circle. Click check. And now we are ready to put it here. So we need to count about 3 circles after the first one where this shaft is inserted. So this is the first one, 1, 2, and then 3. So we want to put it here. Let's zoom in. Like that. Click check. If this is oriented the opposite way, select the flip primary axis. If you were able to put it just like I did, click the check mark. And then now let's put the spacer. If this part went inside, go ahead and click that flip primary axis. If it's just like how I did it, just hit the check. And now let's add the gear. Click fasten mate. Again, the technique is to select that inner circle and then go inside and select that square and then check. And then click here. And then we need to offset. A while ago we put 1.59. This is a 4-inch shaft, while this one is a 3-inch shaft. So let's try to put 0.59. Okay, so these two meshed up. Check. And then now let's add the shaft collar. Select the fasten mate again. Select that inner circle. And select that inner circle of the gear. Click check. Okay, as you can see, the other gear does not move yet. We need to add a gear relation to the two. Click gear relation. And then select, on the left side, select the first revolute and the second revolute that we made. And we are going to put the gear ratio for these two. So we are using a 12-tooth gear meshed with a 60-tooth gear. So our relationship is 12:60. So we could put 12/60 or 12/60 and then click check. And then now you'll see that the gears move. As you move the driver gear, the driven gear also moves. However, if you look closely, so let's hide the crank, hide the shaft collar for now. And let's just expose and then hide this part as well. And let's just expose the gears for now. As you can see, the gears aren't really meshing correctly. Okay, so to solve that, what we want to do is we want this part of the gear, of the 60-tooth gear, the green part, to be around this area. And what we're going to do is we are going to rotate the smaller gear so that the green part of the gear meshes up with the green part of the 60-tooth gear. Okay, to do that, we go to Revolute 1, click on that arrow, and then click on the second mate connector. It could be the first or it could be the second. So let's just go do the second mate connector, right click and edit, and then click move. and we are going to change the rotation angle. So this is going to be somewhat like a trial and error for us. We're just going to try, let's say 50, press enter. Okay, so that was pretty close. So as you can see, it went there. So what if I put 50? Let's see, so it went there. So let's try 60. Okay, so it's between 60 and 50. So how about 55? Looks like that's gonna work. So click check. So all you need to do is, your number might be different from mine, but what we want to do is we want the green part of the 12-tooth gear and the green part of the 60-tooth gear to match up. So click check and then go unhide the parts that we hid. Everything that is in gray, just click on the eye icon for it to show up. Okay, so here goes. So let's look as the gears now actually mesh. So now what we want to do is we want to match up the two green cogs and count how many rotation of the small gear will it take for the big gear to make a full rotation. So let's see. So that's the start. Okay, so that's one rotation of the small gear. That's a second rotation of the small gear. Now this is the third rotation of the small gear. The fourth rotation of the small gear. And this is now the fifth rotation of the small gear. So this is a 12-tooth gear, and this is a 60-tooth gear. If you do the math, 60 divided by 12, that would be 5. So it takes 5 rotations of the 12-tooth gear for one rotation of the 60-tooth gear. So that's the gear ratio of this two. So when you're done with this work, go ahead and share it with me.